Hi everyone. So in this video, you will be able to write positive numbers in scientific notation and use that to compare numbers. Specifically, we're going to be looking at small positive numbers. So let's start with ordering these in least to greatest value. So if we take a look, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers, right? Sometimes I like to think about maybe the middle number or the biggest number or the smallest number I see just to get me started. So I'm going to look at, we have 0 right here. I know that's got to be in the middle because I have negative and positive numbers. Next, I'm going to look for the biggest number I can see here, and I have a debate between 5.1 because we have, if we want, we could put the negative numbers over here just so we could have them on one side and then have the positive numbers on the other side. So then we could kind of, go on both sides of that 0. And then if we look, we have a couple positive numbers, more positive numbers than negative numbers. So we have 0.2, we have 0.002, we have 4, we have 5.1, and we have 5.001. Run out of space there. So if we take a look at this, let's look at the positive numbers first. Which one is the smallest positive number? Now we know it's not going to be one of the 5s, and 4 is definitely bigger than anything with a decimal in front of it. So it comes down to either 0.2 or 0.002. And here's the thing. This number right here is 2 over 1,000. So that's a small number versus this one, which is 2 over 10. So which of those is bigger? The 0.2. So the 0.002 is our smallest positive number. All right, so I used both of those. Now, next we have 4 and then 5 and 5. So I'm going to use the 4 next. And then it becomes a debate between the 5.1 and the 5.001. Which one of those is bigger? The 5.1. Anytime you have, if you think about it, you keep going from left to right. This is a 1, this is a 0. 1 is bigger than 0. So that's why it's bigger. So it'll be 5.1, or sorry, 5. Let's try that again. 5.001 would be next, and then my last big number there would be 5.1. Okay, let's write that a little more cleanly. Now, let's look at the negatives. With respect to the negatives, we have -10 and -2. So 10 is bigger than 2 if we're talking about positives, but the bigger the positive number, the smaller the number is, right, if it's negative. So when we're talking about -2, that is actually bigger than -10. -10 is smaller. Think about it this way. Would you rather owe $2 or would you rather owe $10? When you're talking about negatives, you're talking about, owing somebody money. All right, hopefully that was a review. Let's keep it going. All right. Let's write the following in scientific notation. Yes, we are returning back to scientific notation. So if we look at this one, if you recall from our first quiz and our first set of lessons, what you do here to write this in scientific notation, don't count the zeros. Instead, you put a decimal between the first number and the second number so that you can then count and then put a decimal at the end. And you count the number of times you would have to move the decimal to get them to connect. So if you look at it this way, there's going to be 1, 2, 3, 4, 5, 6 times that I move it. So this is going to be 4.1 times 10 to the 6th. Down here, we're going to do the same thing, but we're going to write it in standard form. We're going to go backwards. So we're going to write this in standard form. So I take 3.8 and I'm going to move it 4 times. That's what this is telling me. Move the decimal 4 times to the right because it's a positive exponent. So I end up with 38,000 as my answer. Which makes sense too, because we know from our chart that 10 to the 4th is 10,000. So this is saying I have 3.8 10,000s, which means 38,000. Okay. Whatever you do, don't think of that number, as the number of zeros. That's not always the case. Quick vocab review, order of magnitude. When we talk about magnitude in scientific notation, we're talking about the exponent that's there. So my order of magnitude here would be 5. Okay, let's rewrite the following into standard form. Now, this is a negative exponent. So before, when we saw it was a positive exponent, we moved the decimal to the right. So when we're talking about a negative exponent, we're actually talking about, again, this does not make the answer negative. We just learned about negative exponents. It means it's something over a fraction, right? So this is like taking 3.018 and multiplying it by 1 over 10 to the 5th. So we're actually going to make this number a lot smaller because 10 to the 5th is 100,000. So it's like we're taking 3.018 and dividing it by 100,000. So to do that quickly, what you do is similar to what we did with the positive exponents, where we moved it to the right. We're now going to move this decimal to the left. So we're going to take 3.018 and move it 5 times to the left. 1, 2, 3, 4, 5. That's where my decimal is going to go. And then I'll fill in zeros for those blank spaces there. So I end up with 4 zeros and then 3018. And that's how you write that in standard form. Okay, now let's write this one in scientific notation. So again, the decimal point has to go between the 3 and the 0. It has to be the number to the left of the decimal when we write in scientific notation has to be a number greater than or equal to 1 and less than or equal to 9. So it can't be 0 and it can't be 10. Okay, so that's a 3. So we have 3018. But what did I do? I moved the decimal over 3 times to do that. But what I did, if you look, this is a very small number. It's 0.003, and I made it become bigger. So I made 0.003 become bigger by making it turn into 3. I need to counteract that by giving a negative exponent. All right, if you think about it, to go back to this, a negative exponent would tell me to move the decimal to the left, and that's exactly what I would do to end up back where I started. And if you recall, that was 0.003. So you could always check your answer by going backwards. Okay, let's compare some numbers here. Which is greater? Well, the first thing you want to look at is the order of magnitude, because if the magnitude is bigger, that number is automatically going to be bigger as long as they're both written in scientific notation. So are they both written in scientific notation? The answer here is yes. The decimal point is between, the number to the left of the decimal is less than 9 or equal to 9 and greater than or equal to 1. So these are both in scientific notation. So all we have to do is look at that order of magnitude. Okay, so even though 3 is greater than 1, that doesn't matter as much as the fact that the 5 is bigger than the 4. So which one is greater? 1.418 times 10 to the 5th. You first look at order of magnitude. If they're both in scientific notation. If they're not, then write them in scientific notation, which we'll tackle in our class. Okay, so which is greater? Well, similar to the activator where I said like a negative number, like negative 10 is smaller than negative 2, but positive 10 is bigger than positive 2. So it's like it's like they're opposites, right? So in this case, when we look at, first off, are they both written in scientific notation? They are. But when we look at the order of magnitude, again, we want to go with the bigger number. The bigger number now is negative 4, because negative 4 is greater than negative 5. So in this case, this one is now the greater number. Because again, negative 4 is greater than negative 5. Right? If we were looking at a number line, here's 0, here's negative 4, and here's negative 5. Okay, so negative 4 is greater. Okay, let's look at the last slide here. So what we're going to do here is we are going to list these in least to greatest order. And you know what? I'm going to stop the video there. I think this would be a great activity for us to start fresh with in our next class. So, all right, I'll see you guys next time.